Right now, you're sitting down, or maybe you're lying in bed, or hey, maybe you're in the bathroom, but you're safe, right? Well, right now, at this exact moment, while you're watching this video, did you know that somewhere out there in the universe, there's something that not even light can escape from? So what is it? Take a guess. Yep, a black hole. And if one day you lost your mind and got too close to one, what would happen? Have you ever thought about it? I bet you have, because it's such a wild thing to think about. I mean, what could possibly happen if you fell into something that swallows everything? Well, first, it would play with you, with your body, with time, with reality itself. And science actually knows how this would go, step by step. It just doesn't know how it ends. Because the place you'd end up, that's where physics just gives up. So let's go. Together, let's grab ourselves a spaceship, but the kind that can go anywhere. Now, before we head off, let's first figure out what a black hole even is. I won't get too technical. I won't bore you, I promise. Okay, grab the sun. Yeah, grab the sun, the giant one we all know. Now, start squeezing it. Keep going. Squeeze. Squeeze. Wait, its radius is down to just 3 kilometers. Yep, you've now got a black hole in your hand. How? Because when you cram that much matter into such a tiny ball, what happens? The gravity at its surface becomes insane. And when I say insane, I'm not joking. This black hole gets so powerful that if you wanted to escape it, well, sorry, you'd have to move faster than light. But here's the bad news. Nothing in the universe can move faster than light. And even light itself, once it goes in, can never come back out. That's exactly why they call it black. Okay, that was a little joke. Anyway, let's keep going. There's also this thing called the event horizon. Let me explain. Every black hole has an invisible line. Once you cross that line, well, good luck. You could have the most powerful engine on Earth. Cross that line and you're never coming back. Let me give you an example. Picture yourself swimming in a wide river, and up ahead, you spot a waterfall. As you swim against the current, the pull toward the waterfall keeps dragging you in. As long as you don't get too close, you're fine. But there's a certain distance, a point where the moment you cross that invisible line, the pull of the water becomes stronger than the fastest you can possibly swim. And no matter how hard you fight, you can't stop yourself from going over the edge. You know, there was a time when this thing we call a black hole was just a mathematical oddity. Like, think of it as the result of those long, boring equations. And honestly, nobody really believed black holes were real. But people and technology got better, and we started finding them. We saw stars, gases, whole galaxies spinning weirdly around patches of space that looked completely empty, right? Something was pulling them, something we couldn't see. Now we know the universe is full of them. I honestly don't even know how to pronounce this number, but some estimates say there are 40 quintillion of them. And almost every galaxy has a giant one sitting right at its center. Ours too. Right in the middle of the Milky Way, there's a black hole 4 million times the mass of the sun. Its name is Sagittarius A star. So get ready, that's where we're going. Yeah, that was fast, but we've already started falling. The black hole's powerful pull is sucking us in. Don't panic though. At first, you won't feel a thing. I mean, falling in space isn't like falling in an elevator. Don't worry. If you shut off your spaceship's engine, you'll just float around like those astronauts you've seen. You might not even feel your stomach drop. But of course, every good thing comes to an end, right? Yeah, now things start to change. Your feet start getting pulled faster than your head. Why? Because you're falling into the black hole feet first. So, by that logic, the black hole is pulling your feet harder than your head. That difference might sound tiny, but it literally starts stretching you in 2 directions. From below by your feet, from above by your head. You start to stretch out. And yeah, when I say you start to stretch, short people might get excited, but this could be your last bit of excitement. Scientists actually gave this a name, and you'll laugh when you hear it. Spaghettification. That's a real scientific term. I'm not joking, because that's exactly what happens. You get thin and long, just like spaghetti. And it's not just stretching. At the same time, you're getting squeezed from the sides too. Pulled one way, squashed the other. First, it's a slight tug, then a weird growing feeling. And the closer you get to the center, the stronger it gets, until you just can't stay in one piece anymore. Yeah, can't stay in one piece is kind of the censored way of saying you get pulled apart down to your atoms. Just think of it like that. Okay, I know. Take a breath, because now I'm gonna tell you something, and it changes everything. But you know what? This whole stretching and squeezing thing doesn't work the same in every black hole. It depends on which one you're falling toward. If you go up to one of those small black holes out there, the ones the size of a ball, then yeah, those effects I just mentioned start way before you even reach that invisible line. But a giant black hole? You know, the ones at the center of galaxies, millions, even billions of times the mass of the sun. That's where things get weird. because they're so big that you could cross that invisible line, the event horizon, without feeling anything at all. If you got close to the black hole at the center of the Milky Way, the difference in gravity between your head and your feet wouldn't even be 2 in 1,000. You wouldn't notice it. So here's the thing, you'd cross that point of no return without ever knowing it. No alarm goes off. 1 second you're outside, the next you're inside, and you can never get back out, and you never even noticed it happen. So let me put it simply, think of it like vanishing without ever realizing it. But wait, hold on a second. Think about this. Maybe right now, somewhere in your life, you've already crossed a point of no return without knowing it. Anyway, let's keep going, but keep it in the back of your mind. Think about that one night. Now, let's get to the weirdest part. Are you excited? Because I am. Time. Yeah, this topic is super interesting, especially when there's a black hole involved. Let's say you have a friend you really love, and while you're falling into the black hole, they're somewhere safe. Okay, realistically, this isn't even possible. But still, let's say your friend is watching you through a really powerful telescope. Yeah, instead of saving you, they're just watching you. Wait, that's ridiculous too. I mean, how would they even save you? Anyway, the thing is, what you experience and what they see won't be the same. Here's how. From their point of view, as you get closer to the black hole, you start slowing down. Your clock ticks slower and slower. Slower, slower. And finally, right at the edge of that line, you stop. You just hang there, frozen. Your friend could see you stuck on that edge for years, even for millions of years, never going in. And on top of that, your image keeps getting redder, fainter, until it fades away completely. But they'll never say he fell in. For them, you stay on that edge forever. But for you, time flows normally. You keep falling. Nothing slows down. There are 2 separate journeys now, the one you experience and the one seen from outside. And the 2 are completely different. Pretty weird, right? And exciting. But honestly, I wouldn't want to go through this myself. Not gonna lie, it's a little scary. And another reason it's scary, the black hole bends the space and time around it. That's what Einstein figured out. Space and time are actually one thing. And this thing stretches, bends, and curves like a dip around anything heavy. And a black hole is the most extreme example of this that we know of. So to you, the universe outside looks like it's speeding up. To them, you look like you're in slow motion. And you're both right. Time isn't something that flows the same for everyone, like you thought. And the black hole shows you this in the harshest way possible. So what about the center? Let's say we cross that invisible event horizon line. What then? The place we finally reach is called the singularity. And this is where all the rules of physics collapse, I'd say. I mean, Einstein's equations start spitting out infinity there, which in physics is basically a way of saying, I give up. Nobody knows what's actually there. Pretty creepy, right? And it's confusing too, because according to Einstein's theory, the singularity isn't a place for anything that crosses that line. It's a point in the future. Trying to escape it is like trying to escape tomorrow. You can't escape tomorrow, right? Because it's in the future. Well, that's exactly how the singularity behaves. Your brain got a little spaghettified, didn't it? But it's not over yet. Sorry. Because Stephen Hawking threw something into the mix. Black holes aren't actually that black. According to Einstein, nothing can come out of a black hole. They only grow. But Hawking found that something very, very slowly leaks out of them. A kind of radiation. So a black hole is actually glowing just a tiny bit, losing energy. And that means black holes have a lifespan. One day, billions, trillions of years from now, they'll completely evaporate and disappear. All that'll be left is that radiation. And here's the most confusing part. The information of everything that went in, including you, because remember, you were the last one to go into the black hole. Somehow, all of it might still be inside that radiation. How? Nobody really knows. This is the very edge of science right now. Still being researched, still being debated. Anyway, you're safe right now, and you didn't fall into a black hole. Not yet. But just think about it. One day, you'll be gone from this world. Your atoms will scatter into the universe. But that giant black hole will still be sitting there for billions of years. And right now, it's out there, and you're right here. You gave it a name. You figured out how it works. You even imagined what would happen if you fell into it. Kind of a weird thing to imagine. But the more you research and learn these things, the more mysterious, the more beautiful the sky becomes for you. Maybe the weirdest thing in the universe isn't the black hole. Maybe it's the fact that you can wonder about it at all.